My distinguished students, once again you are welcome to our lesson series in Math 106. Today's lesson's topic will be on normal distribution. This is another way of calculating probability. Hope you enjoy the topic as we go along. You are welcome. As well known, my name is Dr. Aderugbe Anjorin from the Department of Mathematics, Faculty of Science, Lagos State University. Objective of the lesson. At the end of this lesson, you should be able to know to recognize a new way of calculating probabilities of a given sample space, to calculate probabilities using normal distribution. In this lesson, you shall come across a new way of getting probabilities of the same trial or some trials in a given sample space. The method is different from the previous ones due to some new parameters which needs to be defined below. Getting a good grasp of this lesson, the following terms need to be defined. Mean, which is denoted by mu of a sample space. This may also be defined in two different forms. One, mu equals summation xi divided by n, where xi are the sample points and n is the total number of points in the sample space. Some of the sample mean is defined. Sometimes the sample mean is defined as xi times the probability p of xi, where xi are sample points as trials and pi's are corresponding probabilities. Variance of sample space is denoted by sigma square. This may also be defined in the formula, two formulas below. Standard deviation. This is just the square root of the variance. This is just the square root of the variance and is denoted by SD. The normal distribution is defined by the equation in 3.01, where mu means mean and sigma stands for standard deviation. The area curve of the above diagram of the equation is shown in figure 3.03 here. The two curves. When variable is expressed in terms of standard unit z equals the y is referred to as y equals the expression here. In the case z is normally distributed with mean 0, the value of z are determined in the statistical table of number distribution. Example: the length of 100 planks are assumed to be normally distributed with mean 68 cm and standard deviation 3 cm. How many planks have lengths? 1 greater than 72, 2 less than or equal to 64, 3 between 65 and 71 cm, exactly 68 cm. So you apply the normal distribution to the discrete data. You transform the data to a continuous case, hence a score greater than 72 cm. You assume it is 72.5 cm, then 72.5 in standard unit form is z is equals to that, equal to 1.5. You seek for p of z greater than 1.5 in the statistical table of normal distribution. This gives you 0.06681. Therefore, number of planks having length 72 cm is equal to 100 times the probability, which will give you approximately 7. 2. By the above argument, you consider 64 cm as 64.5. So 64.5 in standard form will give you minus 1.18. You see this in the probability from the normal distribution table as 0.12302. Then the number of planks less than or equal to 64 cm is 100 times that probability, which gives you approximately 12 planks. 3. You consider the same process and obtain 71 between 65 and 71 centimeter has 100 times the probability, which will give exactly 75 planks. The curve in 3.02 shows you the range of the normal distribution. Again, for exactly 68, you assume the same as you assume between 67.5 and 68.5. Then you convert each of these to the standard form and subtract from each other to obtain a probability of 0.13500, and with that multiply with 100 number of planks will give you 14 planks. You have this curve as curve of the distribution as in as shown in figure 3.03. You have the following activities to go along with of this lesson, and I hope if you do them as we had explained above, you will definitely laugh at the end of the day. Summary: normal distribution is another way of determining probabilities of some sample trials in a given sample space. This has been demonstrated here with diagrams and examples. You should have to yourself the normal distribution statistical table for calculating the values of probabilities. Conclusion: you should have known the method of using normal distribution in getting probability of samples in a given sample space with aid of normal distribution statistical table. So this is your suggestion for further reasoning about the hypergeometric distribution random variable. You have the following references for further studies. My distinguished students, I hope you really enjoy the lesson. If those problems in the activity given to you are well treated, you are in a good position of understanding this lesson far better. Thank you. Goodbye.